Perfect. Welcome back, everyone. Today we're going to be learning about CRUD. Well, the first thing we're going to cover is what is CRUD. We'll then talk about what CRUD requests are matched or what behaviors are matched to each request method and what response status are matched to each one of those behaviors as well. We'll then talk about what is request.data and why we're working with request.data. We'll then dive into creating an update method, which is likely going to take us the majority of our class time today. Hopefully, we'll clarify so much in that update method that going through post and delete will be more of a rinse and repeat process. And then finally, we'll go into testing our CRUD features. This testing our CRUD features, I am going to spend quite a bit of time on it today. If we do not finish everything necessary in testing our CRUD features before the time allotted, we will have to go into an afternoon block and cover this. Reasoning for making sure that we're going nice and smooth and slow for this testing our CRUD features is because majority of your Django assessment that's going to be released this Friday will be having the same exact test that we're going to be breaking down today in testing your CRUD features. So I want to make sure that we're going over that nice and smooth. All right. Any questions over what we'll be covering today? Perfect. If there aren't any questions, then let's go ahead and dive right in. I'm going to go ahead and change directory into my Pokédex project here. And before we actually start writing some code, we're actually going to do a little bit of reading as to what is CRUD. Actually, let's take a look at it this way. So CRUD, what is CRUD? Rather than just reading all of this, I'm gonna make us a small note handler here on TLDraw. So CRUD is breaking down the behavior of an actual API and the application. So far, the requests that we've been practicing, and let me go ahead and put this all the way to the top here. The requests that we have been practicing so far are those of GET request, which is actually the read component. But CRUD stands for create, read, update, and delete. Now, this is all in reference to a model, or in reference, we'll go ahead and reference to a model, meaning that it directly interacts with a model view controller. All right. Now, whenever a post request is sent, we'll go ahead and write a little bit of matching here. A post request would be sent from the front end, and it will be processed by the server to create or attempt to create an instance of a model. And then it should return some sort of status codes, right? So the behavior is to create. That's the part that we're working with. The post request is what we'll be receiving from the front end and what we'll be processing through the server. But the front end needs to have a response and needs to know, depending on HTTP status codes, whether the response was successful or not. Well, so far we've seen 200 OK being the most common response code that we have worked with. But now that we're working with different behaviors within our API, we actually wouldn't just have only 200. In this case, we have 201, which stands for created, and we have the other, which would be 400 bad request. And let me actually make sure that that's correct here to make sure that is 400 bad request. Oh, not seeing it in here. Let's see, status code for bad request. Yeah, so it is, right? HTTP 400 would be for a bad request. Great. Let me see if I can open this up a little bit so it all falls inside of one block. Nice. Well, that's our post method, which is for create. And what we can do here is just highlight it with a C. Now, down below, we have our get method, which we've worked with before. Again, this would be sent from a front-end application or whatever's sending the request, right? Then this would attempt to grab an object from the DB. Again, the key here is grabbing an object from the DB. The other one was to create an object from the DB. And the responses that we would receive back from this would either be 200 or 404, right? 200, meaning it was successful. Hey, we found it. Or 404, object not found. And this is our read functionality. All right, does anyone have any questions over those two so far? Awesome. There are no questions. Let's go ahead and keep diving in here. When we come back here, we can go ahead and start talking about put requests, which are for updating data. I keep putting front end, but I think a better description for this would be the requests being sent. So I'm just going to say RQ for requests instead.
Because potentially another backend could be making the request, right?
Exactly. Yes. All right. Yesterday, we just went over server-side APIs. So I don't want to just isolate it to the front end. All right. And here, we're going to attempt to update an entry or an existing object with new data. The behavior here is to update. Now notice that I'm saying attempt, all right? I'm saying attempt for all of these, and we're accounting for the different types of errors that we can have. Well, in put, we could have a multiple amount of errors. Well, if the response is successful and we're not sending back a response body, we can send back a 204, which is response was successful, but there's an empty response, meaning we're not sending back a response body. If we're sending back a response body, we would send 200, and I'm going to put no response, which is 200, okay? If we can't find the object, then we would send back a 404, not found. And then finally, if the data that they sent over, we did find the object, but the data that they sent over didn't fit our validators, then we would have a 400 bad request. And that puts us at our update functionality there. Finally, our last one, which would be our delete method. Our delete method would be sent within the request. And the behavior that we're going to accomplish will be attempt to delete an existing object. Well, again, a couple of things that we can send back. If we're not sending back a response, we could send a 204, no response. If we are sending back some sort of success message, we could send back a 200, okay. If we couldn't find the object, we would send back a 404, not found. And there's no actual data that's coming through, so it's not possible for them to send a bad request, right? And this would be our delete method. So there's all of our existing functionality that we're going to go ahead and implement today. And we're going to go ahead and dive into each one of these boxes a little bit deeper as we continue in our application. So I'm going to go ahead and change a little bit of font size here, try to make it more spacious so we could continue writing some notes. Now I'll continue adjusting this as we go. Perfect. Does anyone have any questions over behaviors, the response status codes that we need to accomplish? We haven't necessarily written any code, but I want to make sure that we all understand the behavior. And I guess something important to talk about is the why, right? Because as of now, I'm saying what all these things are, but I'm not necessarily explaining the why. Well, earlier we talked about a front-end developer that's working with our site, right? And we want to make the interaction with our API as smooth as possible. Well, back in the day, when people were trying to decipher what the proper behavior would be for an API or what is the proper standard or convention for an API convention, they started assigning all these different status codes and all these different methods. And if we're being completely honest with one another, we could probably accomplish all of these three behaviors with either just a get or a post request, right? A get or a post request could be sent, and everything could be processed by the server, and the server could just return a 200 OK, regardless of what the behavior is. But that's not very descriptive or applying the single responsibility principle at all. So instead, everything got broken up. Specific behaviors are for specific methods, and status codes are for the front-end developer to be able to understand what exactly it is that's going on within the server side without actually having to dive into the server code or having to dig into the response message too much, right? Now we're giving them a descriptive response status where instead of writing a bunch of logic to try to process our response and have a bunch of try and catch statements, they can simply say, hey, if response status is 200, meaning that my response was successful, then run this logic. Otherwise, it didn't succeed, so do something else. And that became the API convention and just the standard that is to be maintained whenever you're writing an API. And that's why we're doing it this way. Well, let's actually start writing some code now. All right, we went over what is CRUD. We've covered the CRUD request methods and status responses. And now let's talk about why request.data. Let's go into my Pokemon models. And here are my Pokemon models. I can take a look at my application and I can see all the different fields that belong to my model, along with a method. If I wanted to update this application, or if I wanted to update an instance of a model, what would be the behavior that we need to accomplish, right? Let's go ahead and come over to our views here. There's going to be too much noise on the screen to actually share with TL Draw. So for a better experience, I'm going to go ahead and open it up this way. All right, so here's my models on the left-hand side. And what I want to do is I want to account for a put method that will take in self, request, and maybe another parameter. Go ahead and say maybe a third param. And what I want to accomplish here, for now, I'm going to go ahead and write pass. Well, one, I want to grab an object from the database or send a 404 response because it would be that I couldn't find the object, right? Two, once I have the object, I want to pass, I want to grab the data that the request that's coming in with the request. So grab new data for the object. We would then want to validate the new data for each field. After we validate each data for each field, we want to save the entry, or let's go ahead and say attempt to validate the data for each field. And I guess at this point, we need to have a if successful, continue. Otherwise, send back errors for validation and let the request sender know they sent an improper request. If we continue, we want to save the new data for the object. And then finally, we could either send back a response, which could be an empty response, where the request sender assumes new data entry is successful. Or we can send back a body with the new data of the object being represented. All right. So there's the steps for being able to actually update a model. But then the question is, how do I handle this information as it comes in? Because as of now, I have quite a bit of parameters. I don't necessarily want to go through the process of thinking just yet about how I would validate each one of these fields, but I want to start thinking about how I would send that through a request. Does anyone have any ideas of how we could send each one of these fields through a request? All right. Well, so far what we've learned up to this point is sending parameters inside of the URL pattern. But there's too many parameters, right? And a lot of them might come through with an empty value. And if I try to send this all through a URL pattern, well, I'm going to end up with a bunch of name slash expecting a string of name, then level slash, and my URL pattern might just be excessive, right? If I try to do this through a URL parameter, it might look something like this, where I'm getting back HTTP, localhost, um, at port 8000, which is going to API slash Pokemon slash integer ID, which is going to grab the Pokemon ID slash name, which brings back the string of name slash level, which brings back an integer of level, and so on. And all of this just isn't practical. Like if we take a look at this entire string, this is only up to level. We haven't even covered dates encountered, captured in description. There might be spaces, so we might need to account for spaces in there. So the idea of sending all of these arguments through a parameter or through a URL pattern is a little bit unconventional, right? It's not necessarily the most optimal way to allow users to interact with this. Well, so far, what we've seen, whenever we ping an API, we're receiving a body inside of the request. Whenever we receive a response. But what we can also do in a request is pass in a body. And let me actually build a small playground here. So I'm going to change directory one back. I'm gonna touch, and I'm just gonna call this client.js. I'm gonna go ahead and code client.js. Go ahead, Nick.
So similar to how we sent authentication in headers on some of those API exercises yesterday, could we send the request in a body instead of headers? Is that where you're going with this?
Yes, that's where
Okay.
I'm with this. Yeah. So just like you mentioned, we could set up a headers. Well, we can actually set up data as well inside of a body. Well, we've seen a fetch function so far. So I can say, hey, let's make a asynchronous request called update Pokemon. And this would be an asynchronous request, like I mentioned. I might be a little rusty, so I apologize if this code isn't up to par. Let's go ahead and do let response here be equal to await. This is going to send a fetch request. And this fetch request, well, it's going to go to http// 127.0.0.1, which is my local host at port 8000. We're going to go to API/v1/Pokemon. Notice that I put this within my view of a Pokemon. So in order for this a Pokemon view to be triggered, I'm going to go to my URLs. And I'm noticing that I'm also sending an integer or string. So I need to make sure that I account for that. All right, let's go ahead and let's just send 1 for now. And instead of flooding my entire request here, go ahead and see there. Instead of flooding my entire request with a bunch of fields, what I can do is I can specify, hey, this fetch can also take in, oh, okay, cool, something called body. Is it data or body that goes in there? We're gonna go ahead and go with content type. Nope. Yeah, I'm gonna go with body. I believe that's what it's called. And if I'm wrong, I'll go ahead and update it later on. Where the body would have something like a level. And then here we could set the level to 100. We would have the name maybe being changed, where instead of Mewtwo, maybe we just wanted to say Mew. We would want other fields like, let's say, what can we do here? Description. I know that one is all messed up, so that's a good one to update. Or we can say, this is a new description for Pokemon, and so on. And let me do this real quick. Okay, yeah, so it is body. All right, now this fetch request is going to automatically assume that we are sending a get request. Now, in reality, we're not sending a get request. Ah, I see. It's a little bit more complicated whenever we're utilizing fetch. So I'm going to go ahead and turn this into Axios. We're going to be utilizing Axios.put. All right. So Axios would send a put request to the following, which is the HTTP 127.0.0.1, where the body of the request would have the following JSON object. That JSON object would then be received by our views, and we could actually grab that JSON object through something called request.data. So for now, I'm just going to go ahead and return response and make this response true. And I'm going to print request.data. Well, before we move into putting this into practical application, what's the third parameter that would pass in here. Go ahead, Marshall.
I was gonna say, would it be ID like the method above it since it's
Yeah, so
pulling it in?
just like the method above it, we are still grabbing the ID. So let's go ahead and do that portion there because it is going to receive that parameter from my URL patterns, right? My URL patterns, I'm still passing in the ID to the A Pokemon view. Great. Let's go ahead and take a look at how this works. And we're going to start utilizing Postman again. A little bit of screen handling here. Oh, let me make sure that I'm going to change directory into my Pokedex project. And here I'm going to run Python, manage py, run server. Okay, looks like my server is running. Let's make sure my GET request still works. I send the request, and there it is. I'm still receiving Blastoise. If I send it to request of 1 and get back Pikachu. Well, let's say I want to update Pikachu. We talked about sending a body within the request. And here you can see in this params file, if we click this drop-down menu, there's a body within the request. I'm going to send a raw of application type JSON, or we could say JavaScript, but I'm going to do it JSON. And JSON will be sent within the body of the request. So now I can just write simple JSON. You can say, hey, well, what I want to update will be the captured status. I want to set this to true. And I also want to update the description of this is a new description for Pikachu. Well, if I send this request to a get method, nothing really changes, right? The request is being processed by my server. Everything's coming in properly, but I'm not seeing any request or any print statement just yet. That's because of the method I'm utilizing. I need to change it to a put method. And now when I click send, I get back my response of true. And if we take a look at what we printed from request.data, we actually have that exact object now as a dictionary inside of Python. All right, so request.data, and let me grab that here. So grab new data for the object. Our answer is request.data will hold the information or the request body sent. Yeah, we'll just say sent. We'll hold the request body that was sent. Okay, so there we have our first answer there. We have request.data. We have grab an object or return a Pokemon response. Well, we already have something like that. I don't want to have to rewrite this code over and over and over again. So instead, I'm going to have a method inside of this class that I can just call within my other classes. So I'm going to call this fetch Pokemon. This is not going to accept a request. It is OP. So it's still going to receive the ID parameter there. And for this fetch, I'm going to grab a Pokemon and then return a Pokemon. So that's either going to grab them by title, by name, or by ID. And now I can just say a Pokemon is equal to self.fetch Pokemon, where we pass in the ID. All right, so now I have a method that will always grab a Pokemon or return a 404 error. So there's my answer there. I can do this with self.fetch Pokemon, where I pass in the ID parameter. And then we'll dive into this validating data here shortly. Let's start writing some code. It's like a Pokemon, make that equal to, or let's change this to selected Pokemon. Make that equal to our method of fetch Pokemon, where we pass in the ID. And then we can print selected Pokemon dot name, just to make sure that that works. And we already know where our data is coming in from, so we don't need to worry about printing request.data all over again. I'm gonna go ahead and send my request. Again, I'm gonna receive true. But now in that print statement, I'm seeing Pikachu. If I go back and I just change this into string, I type in Pikachu, and I send my request, I still get Pikachu. I am receiving my same exact response, everything happening through one API view where it's handling either string or the integer of ID. Up to this point, does anyone have any questions over how we've been changing or updating our API view for a singular Pokemon?
Is put usually the most complicated method?
That's a great question. I would say yes. The reason behind it is because of all the possible errors that could happen along the line, right? Not only are you trying to find a something that might not exist, but then you have to actually validate data. If the data is validated, then you have to attempt to update the data, which there could be a problem between you and the database at that point. And then afterwards, you have to decide how you want to return a response to the front end. So that's the reason why we're starting with put, is because it's going to clarify a lot of the questions that we may have for the other methods.
Yeah, it looks like put is has a bunch of the other methods built into it, so the other methods almost seem simpler in comparison.
Right. So like this validating portion for the data, it's going to be almost the same inside of our create method. All right. Well, now that we have this information here, let's talk about this validating data for. So for this validating data, we have a serializer that should be able to account for this information. And so let's say serialized Pokemon now, where we can pass in the Pokemon serializer. So let's say Pokemon serializer that will take in the selected Pokemon as the instance. So far, nothing has been updated just yet, right? Well, I don't want to go through the process of saying, hey, instead of serialized Pokemon just being equal, let's say I want to build a for loop. So I'm going to say for key, comma, value in request.data dot items. I want to go ahead and say serialized Pokemon at key is equal to value, right? Because there's a lot of assumptions there. What if a key doesn't actually exist within the Pokemon model? Well, this would end up raising an error. What if a value doesn't actually match my validation later on? This just isn't a very efficient way of handling this information. Rather, under the hood, something similar to this is what's going to actually be executed. But for me as a developer, it doesn't make sense to even grab a serializer from Django REST framework if it's not going to handle the updating of data for me. So it's actually built in to my Django REST framework. I can grab and pass in the data into it as request.data. And something that I like to do to not manipulate the original values of request.data, I do this data that is equal to request.data.copy. It just makes a copy of the dictionary so that I'm not passing by reference. Instead, I'm just making an entire new data structure that is saved into data. That way, the original value that comes in from the request sender is always available to me. In case I need to run any further logic later on, I still have access to it. And if I need to mutate anything before I pass it into my serializer, I can mutate it freely without concerns of, am I losing the original data that was passed in by the sender? And so I can pass this in as data equals data. Um, but what we've seen before when utilizing a serializer is when we pass in data, it expects every single field in there that has been described by our Pokemon serializer. Well, in this case, because we're not passing in every single field and we don't want it to require every single field, I want it to be a little bit more dynamic. So I'm going to specify, hey, this is going to be partial data or be prepared to receive partial data and set it to true. So let's talk about what's going on in here. Inside of this Pokemon serializer, we are passing in original values straight from the database for the instance, for the selected instance. We're also passing in the new data that is to be placed to its matching field. And instead of place, I'm going to say that is to replace current data and change this within its matching field. And then to allow partial keys and not all fields within serializers, a partial equals true argument is passed. All right, so that's what's happening inside of the serializer. We're passing in the original key value pairs. We're then saying, hey, this is the new information that I have. I want you to replace the current info with the new one that I'm passing in as data and be prepared for it to not be all of the fields that you're expecting. Because if we take a look at the Pokemon serializer, well, the Pokemon serializer says, I need everything. Not in this case. I am telling you that you were likely not going to receive everything. So be prepared for that with this partial equals true. All right. Well, after this, we're going to run into some similar information. We're then going to actually validate said data. So I'm going to say if serial Pokemon dot is valid, then I'm going to serialize Pokemon dot save. And I don't like to necessarily send back an empty response to have the user just assume that it was successful. You can if you really want to have if you're trying to save like your server load, but it's really not going to make that much of a difference if you return a body within the response. So now we can return a response where we can send back the serialized Pokemon dot data because it's going to hold the new key value pairs. And then we'll go into status codes here shortly. Else, well, I can return serialized Pokemon dot errors. And this will allow the user to either get back the errors within the request or update a Pokemon. All right, let me quickly add here all of our answers. So we attempt to serialize this utilizing the Pokemon serializer, where we are going to pass in the object, the new data, and then the partial equals true. Right? So if successful, this is going to be our Pokemon serializer with the object dot is valid. And then we can save the data. So serialized Pokemon. Oh, dot save. And then we send back a response, which in this case, what we're sending back is, where did my star go? There you are. A response holding back the serializer. So serialized Pokemon dot data. All right. Perfect. Let me open it up for questions here. Go ahead, Nick.
Could you scroll down real quick to the logic? So on line 71, Pokemon serializer, it's taking in the selected Pokemon, data equals data and partial equals true. But if you look at your serializer, there's no arguments taken in besides it's inheriting from that class. Is that just is the ability to pass all those parameters in a product of the fact that it's, would you go to serializers real quick?
Absolutely.
A product of the fact that it is inheriting the model serializer class?
It is, yes. So
Okay.
all the different methods and parameters that I'm passing in into my actual Pokemon serializer, they actually exist within the model serializer. And oh, this is going to be
Yeah.
to find them might be a little bit of a hassle, but they exist in there.
I,
That's
I,
of
I trust it. I just want to make sure that that was how that worked.
course. All right. Any other questions?
If I just wanted to return the updated information, how would I do that?
Uh, could you clarify your question? That's what's happening here on line 74, so I might be missing some context.
Okay. I just wanted to make sure because I thought that the serialized Pokemon data was going to be all of it. It was going to return all of the Pokemon's data, not just what you changed.
I see. So you only want to send back the information that was passed in?
Yes, just to so that way, like it's a confirmation. You know what I mean? That like, hey, these only these parameters were changed.
Well, in that case, you would have to build your custom response. It would look something along the lines of, I don't know, let's say, build response, excuse me, that takes in data and it's going to return an actual response here. Well, what this would do is it would take in data. We know that it was successfully updated up above, but you would essentially have to write an iteration to confirm that that data actually matched because you can't just send back the exact body. So you have to say if data.key it exists or is an attribute, is attribute. And here you can pass in the key within the object. It would be a whole mess to build this kind of response because you want to ensure that the key and value pairs actually exist within the serializer.
Hmm.
And the serializer doesn't actually automatically return, this is the only things that we changed for you. Although that might be convenient, they didn't build that functionality out. Does that answer your question? Of
It does, thank you.
course. Carlos?
So going along with that, since they already, so can't you just send back request.data? Since that's the information that they're wanting to change. And if it passed through and actually got updated, that means the information was valid. So you're basically just kind of, I guess, regurgitating to them what they sent to you,
Right.
telling them it was valid and it got updated.
So if you were to do something like that, you would be assuming that every single key value pair actually exists within the Pokemon model. Now, here's what I mean by that. Let's say we have this captured and this description, right? If they were to send an additional key here saying title, say best Pokemon ever, right? and we send this request, the request would be successful because it would only grab captured and description as the ones that meet inside of it, right? But captured doesn't actually exist within the Pokemon model. I mean, title doesn't actually exist within the Pokemon model. So if you were to just send back, hey, this is everything that we've updated, well, then the user is going to assume that there is now a field named title inside of their model, which is not the case. Does that answer your question?
Gotcha. So yeah, so the serializer is just basically ignoring everything that's not already a key in there.
Yes.
Okay, all right, that
Serializer
makes
would
sense.
ignore any invalid input and only grab the proper key value pairs.
So it wouldn't throw an error, it's just gonna completely ignore it.
Let's try it out and let's see it in action. Let me see. We have serializer, everything is running. We have our get Pokemon. Here we have Pikachu. Let's grab Pikachu first, and afterwards we'll send our request and make sure everything works. So I'm going to send this as a get request. Send it. Okay, so Pikachu is currently not captured. This is the current description of Pikachu. I'm going to change this to a put request, and this will be the new information that gets passed into my serializer. Let's see what comes back in my request. And actually, let's send it with that additional title in there. Let's say title. Let's say this is the best Pokemon ever, which is not for the record. All right, so now we go ahead and send our request. Well, now you can see that captured has been changed to true. We can see our description has been changed to this is a new description for Pikachu, which is what I had typed here on line 3. But there is no title, and there are no errors. All right. Well, it only grabbed what actually pertained to the model and ignored anything within that data component that didn't match our model. It just said, oh, there's a title in here. I don't know why there's a title in here. I'm just going to ignore it and leave it to the side, right? The actual logic inside of the serializer doesn't even recognize the title. It iterates through the model attributes and checks if any of those model attributes are within the data. All right.
Yeah, that definitely clears it up. Thank you.
Of course. Any other questions? Perfect. If there are no other questions, let's go ahead and dive into status codes. Now, when we're sending back this request, just like we saw earlier in our TL draw, there's a specific amount of status codes that I can send back. So I need 200 okay, or excuse me, I need 204, 200, 404 not found, and 400 bad request. So let's come back over to our code. And well, where are these coming from? I have get object or 404 being implemented already, thanks to Django shortcuts. But now I want to actually grab my status. And REST frameworks gives us that information. I can import all of my statuses as S. That way they're available everywhere and I don't have to just import a whole list of different statuses. You can just import each one individually if you would like. So I could say, hey, status, import HTTP 200, or I can specify them this way. If we're talking about efficiency, it's better to just import each one individually. I would try to avoid importing whole files at once, just like above. We didn't import the entire views file. We only imported the class that we needed. All right. So I'm going to say from REST framework, import status as S. This gives me access to all of my status codes. Well, this is a response that's down here. So let's go ahead and adjust these. Again, I already have my 404 being implemented in my fetch Pokemon method. When my put request, all I need to establish is, hey, here is a status. Now there is a body within the status code. So because there is a body, what kind of request, or excuse me, what kind of response status should I be sending back?
200.
Perfect. So we'll go ahead and send back a 200. That's if it was successful, right? I ran that is valid and asked it to save it. But if I have errors, meaning the sender of the request sent back some sort of validation error, or maybe the request wasn't built in the correct format and some of those key value pairs don't match. But at that point, it's not my fault, right? I've accounted for that utilizing my Pokemon serializer. I have the logic to render that information. So it's not a 500 internal server error. I didn't make a mistake. The request sender made a mistake. So how do I tell the request sender that they have made a mistake?
400.
Yeah, I would tell them, hey, this is your fault, not my fault. Here's an HTTP 400 bad request. All right, so now as a user, when I receive this information, well, I can say, oh, well, this isn't like an error that's on their side. It's not that the data that I'm passing is formatted properly and that the API endpoint is just not working correctly. Instead, this tells the user very explicitly, no, this is your fault. Here are the errors. You need to adjust it on your side. All right. And that's how we applied our status codes there. Right, so let me actually move all of our logic down. Nope, I'm gonna keep it as such. I try to write as many notes as possible because I know this is a monster of a view as well. And it's also going to be very relatable to everything else. If I take out all the comments, it's actually not that many lines of code. It looks like it's 1, 2, 3, 4, 5, 6, 7, 8. It's only 8 lines of code. All right. So it's just a lot of commentary that's going on inside of this view. That's why it looks so massive. All right, go ahead, Carlos.
So, and I guess an example of a 400 would be like, for example, if name is expecting a string, but you give it integers, then that's when you would get a 400.
Yeah, let's actually take a look at an example of that, right? Let's say, for example, captured. Let's say I change this to 20. We know that that's expecting a Boolean, but now I'm sending an integer. But now if I send my request, I get captured must be a Boolean value. And it's telling me 400 is a bad request. All right. Any other questions?
So ultimately, a lot of the error responses, you could be really, really lazy and just give a crappy 404 for everything. But in order for troubleshooting and for end users to actually know what's going on, you want to make it better than that, right?
Exactly. Yes. You want to design your API to be as descriptive as possible for the user, right? For example, the Now Project API that we were working with yesterday, there was only 3 status codes that it was giving me, and they weren't very descriptive. For example, I never got a 400 bad request from them. They only gave me a 401 unauthorized. They gave me a 404 not found, which they were using as a blanket statement for pretty much everything, and then 200 okay. Those are the only 3 type of status codes that they were providing for me. That's not very dynamic per se. It works for them, but that's not what a proper API should look like. All right. Any other questions? Okay, great. There is a portion for testing inside of part 1 towards the very bottom of our curriculum. We're going to go ahead and save that towards the end of the class. I would like to tackle all of our testing at the same time and isolate that time block. Currently, as of now, it is 9:58. If there are no other questions, we can go ahead and pause the recording here. All right, everybody. Before we went out, we actually created a Pokemon view for being able to handle a put request. We went over how to grab a Pokemon and creating a class method, or excuse me, an instance method, a class instance method, which is here in API view, where we have the get or fetch Pokemon that will get a Pokemon or return a 404 errand if the Pokemon doesn't exist. We then have a serializer that's able to handle partial data, and we have our validators there. Well, the next things that we need to have, or that we need to create here are going to be our delete and create requests. So starting off with delete. Well, the delete request is actually pretty simple. We're going to go ahead and make the method of delete. We know this is going to take self, request, and ID. We'll then grab a Pokemon. which is equal to self.fetch Pokemon ID. I typically like to return a success message. So I'm going to save the Pokemon name. So I'm going to say Pokemon name or selected. Let's leave it as Pokemon name. And I'm going to make this a Pokemon dot name. All right. From there, I'll go ahead and actually delete this Pokemon. So I'll say a Pokemon dot delete. And then I'll return a response stating that Pokemon name has been deleted. Now, because I'm returning a message and it's not an empty response, I'll set my status to HTTP 200 OK to make sure it's explicit and not implicit there. I don't need to touch the request because I don't need anything within the request body. The delete functionality is going to match the ID, and then I'll be able to delete a Pokemon. So let's go through that process now and see what it looks like here. So I can run a GET request for Pikachu. Pikachu comes back. If I send a put request to change the ability to capture to false, and I send my request, you'll see that it is now false. And now if I send a delete request, well, Pikachu is going to be deleted. And Pikachu has been deleted. All right. Well, now if I send a GET request and I try to find Pikachu, I'll get, hey, this Pokemon doesn't match any given queries. So I get a 404 not found. And if I try to pass in the ID of 1, I still get no Pokemon matches this given query. So I've successfully deleted Pikachu from my database. Again, we grab the Pokemon. I save the name so I could use it inside of the message down below. But I delete the Pokemon. The reason why I'm saving the name is because once I delete the Pokemon, this data no longer exists. So I'm saving it to a new variable so that I can then use that variable in my response message. Any questions regarding the delete method? All right, let's hear it, Carlos.
I guess it wouldn't be on the delete method itself, but so when I was my previous job, so we were handling a lot of database stuff. And so instead of actually dropping something from the database, and it might have just been the design decision, I guess, but instead of dropping it from the database, it would just basically give it a flag of like D for deleted. And then any other results whenever you query the database, just filter out those. So what's 'cause, I mean, we're expected to keep data for, I think it was like 10 years or something like that. So is that more of a design thing, or is that really more of is it common? I guess that's the question. Like instead of actually dropping something, just kind of keep it, but mark it, or maybe move it to a different table, or I'm not sure how it would be.
So I'm not sure what you were dealing with. Typically, that applies to client data and only client related data. If it's something that's hard coded or something that, like, let's say you have a product, right? And you're making an e-commerce site, you're making the backend for it and handling all the database management for it. Maybe you don't want to, it's kind of a design-based decision. It's up to the person that's creating the backend and also up to the company. So some companies have some sort of standard as to how long they have to keep records for. And in the case that happens, the typical thing that I've seen is inside of the models, there'll be like hey, is active or is deleted that's set to a Boolean value. And then that's the way they'll manage that information. They'll just go ahead and turn this into true. That way it doesn't populate anymore, or they'll turn it into false if it's coming back. And that's just in case you need to restore data rather than having to rewrite records if the records are still there.
Yeah. Okay.
Of course. Did that actually answer your question?
It did, yeah. I mean, the question was, is it more of a, like, what is it, what's more common? But it's, I guess, not necessarily more common or not. It's just depends on
It just depends
what
on.
the purpose of that. Yeah.
Right.
Like,
Of course. All right. So now we have our delete functionality, we have our get method, and we have our put method. Well, what if I want to create a Pokemon? If I want to create a Pokemon, that would fall inside of my post method. But where should this post method live as far as class-based views? Should it live inside of the a Pokemon view, or should it live inside of the all Pokemon view?
I put mine in the all
Okay, and why did you make that decision?
because because you don't need the ID.
Yeah, perfect. So we don't need the ID, right? And then I also want to think about it from a scoping decision, right? What I'm creating a new record in is in the existence of all of my Pokemon, right? I'm not creating a new record within a Pokemon. If I had like a sub model that was attached to a Pokemon, then maybe I would create a post request that's tied to a Pokemon. But currently, I am creating a new record within all Pokemon. So that's why our post method would go up above. Right? We would have a self and request. In this case, I would utilize data, which is coming in from request.data, and I'm going to copy it. I am then going to attempt to create a new Pokemon, which will be through my Pokemon serializer, where I'll pass in data as data. I'll attempt to validate my data. So I'll say if new Pokemon dot is valid, then I'm going to save the new Pokemon and return a response, where the response will have the new Pokemon dot data attribute, and my status will be of HTTP 201 because I've created a new entry. So 201 created. Otherwise, I'll go ahead and return a response of new Pokemon dot errors, and then I'll specify that the status was of a bad request. And that's how we can create a new Pokemon. All right. So now that I've created a new Pokemon, I can go ahead and test this API view here. All right. So here's my Pokemon API view. I can send to try to get Pikachu one more time. It didn't come through. I can go over to my models and check what exactly it is that I need. So as of now, I need a name. It doesn't look like I need a level. I don't need a date encountered. I actually don't need anything other than just the name to be able to create a new Pokemon. So let's go ahead and apply that. I'm going to come over, change this to a post request, where I'll say the name is of Pikachu to try to recreate my Pikachu one more time. Well, if I send it to this URL endpoint, I'll get, hey, this method is not allowed. That's because I'm currently sending it to the one that's holding an ID. But if I just send it to all Pokemon, we'll say so it's telling me that the moves field is required. Okay, great. So I'm going to go ahead and add moves and send that to an empty list. I send back a request, and now I'm getting an internal server error of 500. Okay, well, what's happening here? Why am I getting an internal server error of 500? Let's see. API v1 Pokemon, not really telling me much. Let me take a look at my server. All right, so the create method does not support writable nested by default. Write an explicit create method for a serializer. Okay, or set read only to true on nested serializer fields. Fantastic. So it's giving me the answer here as to how to manage those. I apologize, everyone. I have a lot of background noise. I'm gonna go ahead and take a 5 minute break real quick, and then we'll come back to this. I apologize. So currently it is 11:13. We'll be back in 5. Welcome back, everyone. I apologize about that hiccup. So currently what we're seeing is a problem with our serializer. Our serializer has a create method, which is handling for our moves. And if we go over to our serializer up above, well, my Pokemon serializer does have a move serializer that has a many-to-many relationship. Interesting. And I can see there that I have a many equals true. Well, as I'm receiving data, you'll see that if I pass in square brackets, it's maybe I tried to analyze how it works. But here it tells me, hey, the assertion error for the create method does not support writable nested fields by default. So there's the error there, right? It's telling me, hey, we can't just write something that already had with a predefined relationship. If I want to do something like that, well, then I need to create a create method, or I can set the read only to my serializer. Well, let's try that first method here. All right, let's go ahead and say I change it into read only equals true. And let's see if that changes any of my behavior inside of my other views. All right, if I run get Pokemon and I run 5, that should return Blastoise. So Blastoise is working great. Okay, let's go ahead and let's say I want to update Blastoise. And I want to have Blastoise to also have the moves of 1. Let's send it like this. So I'll go ahead and send my put request. It should be able to update it so that Blastoise now has the moves of 1. And actually, let's make sure that we do have the move of 1. Let's go to HTTP, localhost. That didn't work. Okay. Localhost 127.0.0.1. And instead of Pokemon, we're going to grab from moves to see what moves exist. Okay, so we do have the ID of 1, which is to Psychic. So now I'm trying to teach Blastoise Psychic. Well, I sent over my request, and it looks like my request worked properly, but moves didn't change. Well, let me take a look at my server here. Put went through, it was successful, but it didn't change. Well, that's because I have the read only. If I take off the read only, and then I send my put request, non-fielders, invalid data type, expected dictionary but got integer. Yeah, so this is turning into a whole managing of many-to-many relationships is going to be a whole different animal in its on its own, right? Invalid data, expected dictionary but got integer.
You need the ID equals 1 or as the
So no, it's actually expecting like a whole object. If I do something like this, I'm pretty sure this will still not work. Let me go ahead and send it. Yeah, see, so it's still going to return an error, and that's because of the update method. All right, it's telling me the same issue. So it's saying, hey, we don't support this. If you want to update something, it can't be within this many-to-many relationship portion. So I would have to have a completely separate API view that would handle how to update this many-to-many. But that's beyond the portions of this current class. Right? So to make it explicit, well, how do I actually change this functionality? Well, this is where having separate serializers comes into play. And I believe I mentioned something along these lines when we were first creating serializers. So now I'll have a Pokemon detail serializer that I'm going to activate upon get request only. I'll go ahead and say read only equals true. Because for everything else, I don't want the moves to be included. Right, so my Pokemon detail serializer will return all of the details between the Pokemon. And then we have my Pokemon serializer, which should still work perfectly fine. So now I can go back to my models, go over to my views, and I can change this to Pokemon detail serializer. Great. So everything up to this point should be working just fine. All right, if I come over to my models, oh, excuse me, not my models, my serializers, we'll see that we have our Pokemon details, which will still work great. I can come up above. I have my Pokemon details imported. I also have the Pokemon serializer for creating the one instance. But in this get request and all of the ones below, oh, hello. I'm going to go ahead and change this to Pokemon detail. And also for my put request, I'll go ahead and change it to Pokemon detail. This way you can manage specific requests to that one Pokemon and still return the status. Well, now, when it comes to this post method, this Pokemon serializer is not going to care about moves. So let's go ahead and turn this back into Pokemon. Let's run our get requests to see what's currently in there. So we can see that Pikachu doesn't exist as of now. We can change this to be of name and say Pikachu. And now, when I send my post request, get moves, this field is required. Interesting.
Did you exclude it from the serializer field?
Yes, that's what was going to be my next step here. So I'm going to go ahead and run excludes. And this should be a list of moves. That's why I don't like doing many or many relationships inside Django's ORM this way. Okay, so it looks like I have an internal server error here. And it's exclude, not excludes. One more time, and there you go. Now Pikachu has been successfully created. It is of level 1. It has currently been captured. If I run my get request and I press add a 7 as my parameter, I get Pikachu. If I wanted to update this request or update this information, I can change level to be 20. I can change the captured status to be true. And I can also change the description. Say this is an electric type and will evolve with a thunder stone. All right, so I send my request. You can see all my information has been changed. I already saw get, I saw put, we saw post, and finally I can send my delete request and Pikachu's gone all over again. I get Pikachu has been deleted. Let's go ahead and recreate Pikachu just so that he is still within our database. Send my post request. And then I would receive it as such. All right. I see a hand up from Carlos. Let's hear it.
If you ran another post like exactly the same as it is right now, just hit send, it would give you a 400, right? Because you're duplicating the name. I think the name is supposed to be unique. So when you do the serializer, it's valid. It's running through all the validators, right?
It is, yes. And let me
Yeah.
actually make sure that the name is unique, just like you said. Let me go over to my Pokemon. Yeah, so it is unique equals true. So if I try to send it again, get name, Pokemon with his name already exists. All right. Does anyone else have any questions regarding the CRUD methods and how to handle statuses?
Yeah, I have one.
Let's hear it.
It might just be like confusion, but can you go back to your views?
Absolutely.
Um, I don't understand how you're making a put request with only the detailed serializer because it was read only.
Yes, so the read-only portion is only to the nested serializer of moves. So if I were trying to send in a new moves, for example, if I go over and let's say I go to put, I know Pikachu's in the database now. I don't remember what the name was. And I send this request. It's the same exact values, but it's still gonna work properly. Okay. Well, now if I go and I try to add moves and I say that in moves, I want there to be the ID of 1, 2, and 3, and then I send my request, it just ignores the fact that I'm trying to update moves because I told it that that is only on a read-only it's only to handle it with a read-only perspective. Now, if I wanted to create a method that would be able to actually handle this move serializer, I could do that as well. And we can cover that as additional information, but I do want to get through the testing first before I dive into how to handle that many-to-many relationship. Did that answer your question, Scott? All right, awesome. Daniel?
Is there a way to reuse IDs that you've deleted, such as like how you deleted ID one? And is there like a way to like reassign Pikachu back to ID one?
So in order to do something like that, you would have to implement what Carlos described earlier, where rather than deleting the actual record from the database, you would keep a you would keep it, it would just be inactive, right? There's no way for you to essentially just cache the ID that previously belonged to this value and then try to re-grab that ID or have some logic. You could have some logic that will do it, but it's not going to be good for your server as far as longevity to be able to hold that much information. Right? If you're, let's say you're something like Facebook, where messages are being deleted at the cyclic, right? And those messages are being stored inside multiple databases, inside of multiple servers, X, Y, and Z, right? They do have a method of, hey, you can recover deleted messages or deleted messages are stored somewhere else. But when those deleted messages are stored somewhere else, they never stopped living inside of the database. They just got flagged saying, hey, this message is no longer active, right? And then you go into your deleted messages and you say, oh, well, now I want to actually delete everything. And then it tells you doing this action will permanently remove this from your data or something along those lines. The moment you click yes on that user interface, that's when those records actually get removed from the database. And there's no way to like recover them or assign them back to some sort of ID. Does that answer your question, Daniel? Of
It does. Thank you.
course. I think big picture, if you're utilizing something along the lines of volumes, inside of PostgreSQL, you can probably hold some cache data that you can recover by pinging like older versions of your database or older end states of your database, depending on how often you back up your records. But that's a whole different animal to just tackle rather than just making the entry again. All right. It doesn't seem like we have any other questions. So since we don't have any other questions, let's go ahead and dive into how to build these tests. So I'm going to crash my server, change directory into tests. Inside of tests, I'm going to touch test crud.py. And then I'm going to actually test crud.py. Now, in this testing portion, I'm isolating my tests just to make sure that they're in their own separate files. But know that this would just essentially follow the test views, right? I guess we could put it here in the test views rather than utilizing a new test file. Let's go ahead and just put an announcement in there saying this is where Crud func is being tested. We know our get request is working because we actually tested it here up above. And we also tested it here. Well, now let's test that only one field of a Pokemon is being updated. So let's go ahead and say update a Pokemon. This is going to take in self as before. I'm now going to start using client a couple of times. So instead of just writing client all over and all over again, I'm just going to create a setup method that takes in self and will assign client to a client instance. Then I can just change my code, say self.client. That way it's just one client consistently making these requests. All right. And let's make sure I didn't break my test suite before we start writing anything. Say Python manage py test, go into test, and we're going to test views. Okay, so I was able to find two. It looks like we have the ID of name Pikachu. Okay, so it looks like the last time we did this was before we established the many-to-many relationship. So that's why our answers aren't up to date. We can see that moves has now been added where we don't have that below. So let's go ahead and try to adjust our answer here by adjusting our fixtures. Or actually, we just grab our fixture. Let's see. None test. We're going to go to Pokemon app, fixtures, Pokemon data. They all have moves. Great. And just to clarify, this is happening from the get all Pokemon. So this should return this exact list. I can come over to my views, or excuse me, not my views. Let me close this up now, because now there's a lot of stuff occupying my screen that I didn't want. I can come over to my test, go into answers. Oh, it looks like all Pokemon is holding moves. Interesting. So where is this list deferring here? Level 14, which is not equal to ID 1 moves.
Doesn't have anything to do with the serializer and how we excluded moves.
Oh, it does. Yes. I have to change my response there. Let me come over to my Pokemon app views. See, and that's why testing is good, because now I just caught, as I'm refactoring my code, I broke a previous endpoint. So this here should be details. And now if I run my test, it works properly. All right, fantastic. Everything's working great there. Let me close down this Pokemon app. Don't need the views. Let's go into my testing views and actually start this testing application. Now here, I'm going to go ahead and say that the Pokemon that I want to update will be of Eevee, right? We have the current Pokemon already. So let's go ahead and make sure that this Pokemon actually exists inside of my fixtures. So we have Mewtwo, we have Blastoise, Pikachu, Charmander. Oh, we don't have Eevee. There's Eevee. Okay, so this is the current Eevee that exists. Now I want to update that information. So in my testing views, I'll go ahead and say, hey, I want response to be equal to self.client.put. I'm going to send a put request. This put request will go out to a Pokemon, and let me make sure that's what I named my URL here. So I actually named it single Pokemon. I'm gonna copy and paste that to make sure I don't mess it up. And the arguments that I'm going to pass in could either be the ID or it could be the name. So in this case, I'm gonna pass in the name Eevee. Great, so there's my Pokemon. It's being tested. I gave it the proper arguments. Well, what about data? The data that I want to pass, I'll just go ahead and pass in the same exact stuff that I passed over here. I'll pass in the level that captured. Okay, so I'll say data is equal to the new level, which is true, or excuse me, the new level, which is currently it's 8. I want it to be 20, and then the captured. All right, so now we have our description. We don't need anything regarding description. We have our data. We have the API endpoint that we're sending it to. But there is one more thing we have to specify. We actually have to specify the content type that we're sending it. And the content type that we're sending is of application/JSON. Now, in your assessment, you're not going to get asked to build test, but it is important that we know how testing works. And so there's a reverse call to our URL with the correct URL parameter. The data that I'm passing in within the request body, which is similar to what we're seeing here in our client, right? Axios.put. There is a body in the request. Or inside of my testing views, I'm just putting it in as data. And the content type is of application/JSON. This is just letting my Django application know that what I'm sending is JSON data. All right, go ahead, Carlos.
Why is the content type required during the test, but not during a normal put request?
Content type required during. This is because it's happening from the server side, and I'm sending. It's kind of how fetch works against Axios, right? So, fetch versus Axios. In Axios, the content type is assumed, whereas in a fetch request, if I'm describing a method, which needs to be explicit, it can't just be the attached method to axios.get or axios.put. No, I have to explicitly state the method. I have to explicitly state this is the data body. And I also have to explicitly, within options, I need method, I need data, and I need content type. Right? If I don't pass in a content type, it assumes that it's application/JSON, but this value is always being passed in. It's just either being assumed for me or I myself am explicitly passing it in. In this case, what our client is doing, it's almost as if we were sending a pure fetch request. Does that answer your question, Carlos?
Yes, yes, it does.
All right, great. So now there we have our response. Our response is going to come back. And as of right now, this should pass So I can come over to my Pokemon, or excuse me, I can come over to my views. And I can ensure a couple of things. One, I want to ensure, so self dot subtest. I want to assert that I want to assert that the response status code is the same that I'm passing in my views, which here in my views for a put request, once I find it, I'm sending back a 200 OK because I actually have a response body. So I can check, hey, this should be of 200. Awesome. So there's the first check. I get back the correct status. Well, now how do I actually check if it worked? Well, in order to do so, I can go ahead and grab both my serializer and Pokemon if we wanted to. So I can say from Pokemon app, comma serializers, or excuse me, serializers, import all. And here I'm just essentially going to rebuild the logic that's coming back here. I'm going to say Pokemon is equal, because this is after the request was completed, to Pokemon detail serializer, because that's what's coming back from a put request, where the Pokemon that I'm going to serialize will be of Pokemon.get, or excuse me, .objects.get, where name is equal to EV, and then .data. And now I can self.assert equal that Pokemon is the same as my body. So I can say body is equal to JSON.loads response.content. And I can check the body. Let's take a look at what kind of happens here when I run this test. Okay, so I see it went through, it was successful. The original values of this Pokemon, Eevee, which again I need to grab from my JSON, is where they are of level 8, and their capture status is false. In my test view, I am sending a request, which is a put. Let me put this side by side here. I'm sending a put request where the ID is Eevee. It fetches the Pokemon and returns that Pokemon instance. It takes a copy of the data, which is level 20 and captured, being true. It serializes the new Pokemon data with partial equals true. It checks if it's valid. If it is, it saved that entry and returned the response status. So everything was great. It worked correctly. I can then ensure that the response actually worked, or that the status code actually worked. So here I'm getting 200. And then I can grab that Pokemon details data. Right? I can also change this so that there's multiple assertions where I can check those two fields, if those two fields had been updated. But in this case, because I know it was successful, I know the behavior here, I can just send Pokemon details.get data, which is grabbing the newest version of that current Pokemon inside of the database. Load the response JSON, because that is what I'm sending back. And then check them when against each other. Now, another thing I could do, if I really wanted to get nitpicky with it, I can specify data equals outside. And then here I can say data equals data. Now, when I grab this Pokemon serializer and I grab the content from the request, well, what I can do is I can say, all right, rather than worrying about the content of the request, because this was successful, I actually want to make sure that the Pokemon changed. So I can say for key, comma value in data.items, Pokemon dot key. And hopefully it lets me access it this way. So if Pokemon key does not equal the value that I'm passing in, and actually I can probably do this like this. And that's already returning the data attribute. So I can say Pokemon, yep, do it this way. Key does not equal the value that's coming in from my data, then I can fail. Another one, self dot assert true, which is equal or say true. And if I run my test this way, this should work as well. And so now I'm iterating through those keys, making sure that that Pokemon dictionary or that newest Pokemon entry actually exists. Grab those values and ensure that that there's not a mismatch between the new Pokemon data that was currently saved inside of my database and the values that I'm sending inside of my put request. All right. Let's do. There you go. Does anyone have any questions regarding the put request test here? Perfect. If no one has any questions, let's go ahead and make our test here. 004, which is going to be for delete a Pokemon. I'm going to grab self. And then here, I'm going to send a response, which should be equal to self.client.delete. Again, what I'm going to be sending here, we'll have a reverse call over to single Pokemon, which I believe is what we named it earlier, with the arguments of Eevee. There's not going to be a data attribute, so I don't need to worry about content type or anything like that. Now with self.subtest, I can ensure that the status code matches. So I'm going to go ahead and run assert true, or excuse me, assert equals, which is going to have the response dot status code and 200. Now that I know that was successful, because in my views, I am returning 200 in my delete method, and I apologize, Carlos, I'll get to your question here shortly. I don't need to necessarily check the response message. Instead, what I want to do is I actually want to check that this Pokemon has been deleted. So now I can ask let's see how we do this. Let's say Pokemon is equal to Pokemon dot objects dot get, and then pass in where name is equal to Eevee. For now, I'm going to go ahead and self.assert true and pass in true. And I'm gonna actually print this Pokemon. I'm expecting to see an error. Okay, great. So I'm getting this Pokemon does not exist, matching query. So to do this, I can try. If this succeeds, I want the test to fail. And then I can accept by letting my test pass. Right, the Pokemon no longer exists, so this should fail. If it doesn't fail, then I have an error. Right, so I'm testing the functionality within my database. I have deleted Eevee, and I can go into creating Eevee. But before I do that, let's go ahead and pause for questions. Go ahead, Carlos.
This is more of a, I guess, question on the flow of your entire test file. So if you were to delete a Pokemon, you delete Eevee, and then your next test is trying to get the Pokemon to get Eevee. Eevee's gone from the database, right? Like from the one that got created. So you would get an error if you try and get Eevee.
I
You
see.
would have to create Eevee and then try and get it within that next test.
Yes, so the database would persist from top to bottom, right? So any actions happening in test 01 would, if I'm changing anything inside the database, it would also show. Any actions happening inside of test 2, it would also show inside the database. That JSON data is not being reloaded, right? So it's only being loaded once from these fixtures when I start the test suite. And then after that, the database stays consistent until the end of the test suite. Does that answer your question, Carlos?
Yes, thank you.
All right. So finally, let's go ahead and make our last test here, which is 05 of create a Pokemon. It's going to be self. Again, we'll take in a response, which is going to have a client sending a post request. Now, this post request will be of a reverse proxy over to, and let me figure out what it is that I name my URLs. I'm pretty sure I put all Pokemon. Great. There's a little bit of capitalization there, so I need to do better with my consistency. Here, I don't have any capitals. Up above, I do, so I'm already starting to run into some consistency issues. That's my fault as a developer. So let me go ahead and paste that in there. So all Pokemon. There isn't going to be any arguments in here, but I am going to have a data payload where I'm going to check data. And all I need to be able to create a Pokemon is a new name. So in here, I shall pass in Eevee. And finally, I need that content type of application/JSON. Let's make sure that looks similar. Okay, good. We have my response built. It's being sent to all Pokemon as a post request to be able to create a new Pokemon. From there, I can say with self.subtest, I want to test that the response dot status code is of 201. And then I also want to make sure that this Pokemon now exists within the database. Let's go ahead and run this with a try block. So you can say Pokemon dot objects dot get, where name is now equal to Eevee. If I'm able to successfully run this query, then my test should pass. And I can catch my exception because if this fails, with a failure for my test. Well, now if I run my database here, okay, so I am getting one failure. And that is because I'm getting a 400. not a 201. Okay, and this might make me change what I just said to you, Carlos, because it looks like my database is restarting every single time. So let's go ahead and make sure that that's what's happening here. Currently I'm sending my response. Let's go ahead and print response dot content. So I come over and here I'm getting name. This Pokemon name already exists. So I was actually wrong earlier, Carlos, when I told you the database persisted. It looks like the database is restarting upon each independent test. And that's why Eevee still exists within my database. All right. So let's actually clarify. Now that we've clarified that, let's run this delete request first, since we know that works. We can run the delete request, delete Eevee, and then recreate Eevee. Okay, great. So we can see that Eevee was deleted. We then create Eevee. We get that 201 created. My query works, so it's able to pass my test. And I have my exception there for a failure. Let's see what happens if I were to send back something improper. Let's say I just send back something along the lines of title and say hello. Well, now I get a failure, and it looks like fail is having some sort of assertion error. I think something inside of the Django test suite has changed recently. Probably a new version of Django has came out between the last two cohorts. And it looks like fail requires an additional argument. So it's having a little bit of a syntax error. Let me see. Fail message. Oh, that's what you're looking for. Okay. There you go. So it looks like I have two failures. Pokemon matching query does not exist. Let me see what is going on here. During handling, Pokemon matching query does not exist. Name Eevee. Okay, so there's my first exception, but I did a try and catch block. Oh, but now 005 is failing. Why is 005 failing?
But the way you changed it, I think that's what it's supposed to do, right? Because you made it to where it breaks on purpose? No, hold on.
Give me a second here. Interesting. Oh, my subtest. That's where it's failing because it's no longer returning it's not a successful request, so it's returning a 400 for a bad response. So this is the first failure, right? We have a bad request. We have a 400, which is not equal to 201. And then we have the exception. Exception as perfect. Yeah, so this is actually working properly. All right, it's able to grab both of the failures there, where one, this query doesn't work, so it fails my test, and two, my response status code was of 200 of not successful. Well, now I can change it back to name, pass in Eevee.
Yeah, to make that test proper, you would have left data what it just was to that bad title or whatever. The status code would need to be changed, and you would in your try except block,
Which
the assert true would be false or fail, and the fail would be a pass, right?
right. If what you're
Okay.
trying to look for is for a failure.
Intentional failure.
Yeah, an
Okay.
intention. All right, so now we run it, and all five of our tests are passing. Okay, we are a little bit over. I'm okay with staying a little over now. Does anyone have any additional questions when it comes to testing of the crudding application, whether it be on your update, your delete, or your post functionality? All right, everybody. If no one has any questions, this will be up on GitHub. Let me go ahead and stop our recording here.